While Earth enjoys an eclipse, a NASA probe is ready to touch the sun. Let's talk about today's news in migration world. To get all updates, make sure you subscribe and hit the notification bell. The sun is having a glamorous year. It's at solar maximum, the peak of its 11-year cycle of storminess. It's been hurling great blobs of charged particles at Earth on a regular basis, intensifying the high-latitude auroras. And in a particularly flamboyant star turn, the sun on April 8th will hide itself behind the moon, offering tens of millions of people in North America a chance to experience a total solar eclipse. Overshadowed by all this is a risky NASA mission that's about to send a spacecraft hurtling practically within spitting distance of the sun. The Parker Solar Probe, launched in 2018, is designed to touch the sun, as NASA puts it. On Dig 24, the probe will make its closest pass, coming within 3.8 million miles of the surface, having been accelerated by gravity to more than 430,000 miles per hour. No spacecraft has ever flown so fast or so close to the sun. It is a voyage into the unknown, said NASA's top science administrator, Nikki Fox, who tells everyone that it's the coolest, hottest mission under the sun. At a cost of $1.4 billion, this mission is not cheap. That NASA would invest so much money and effort is a reminder that the sun, which is so basic to our survival, is not fully understood. We live in the atmosphere of the sun. Anything that happens on the sun, we feel the effect here on Earth, Fox said. If the sun sneezes, the Earth catches a cold. There's also a more subtle agenda in this mission, advancing American aerospace prowess. The technological innovations can be applied to future space endeavors, at a time when many countries are sending probes to the moon, Mars, and elsewhere in the solar system. It's whether we stay at the top of the world or somebody else will step in, said Noor Rawafi, project scientist for the mission and an astrophysicist at the Johns Hopkins University Applied Physics Laboratory in Maryland. His eyes brighten as he describes the amazing feat of the spacecraft. We will be almost landing on the star. How to survive a visit to the sun. Fun fact, you can't land on the sun. There's not actually a distinct surface. When scientists talk about the sun's surface, they are alluding to the photosphere, the lowest visible layer of the atmosphere. At its closest approach on Christmas Eve, the Parker probe will be 7 times closer to the sun than any other spacecraft has ventured. NASA engineers hope the public understands that getting this close to the sun is not a day at the beach. This is a high-risk mission. When you go into the atmosphere of a star, it is really harsh, Rawafi said. The probe is festooned with instruments that are taking measurements of the solar wind, including temperature, density, and velocity. The solar wind reaches to the outermost edge of the solar system. Earth is fully immersed in it, but thanks to our planet's magnetic field, we are usually protected from the most harmful solar radiation. We ourselves are living in that environment, but we don't feel it because we have a geomagnetic field that shields us from these hazardous energetic particles and these explosions from the sun, Rawafi said. That's why we have life on Earth. The solar wind is protective too, because it limits the impact of cosmic rays, particles moving at tremendous speed and coming at us from all directions in our galaxy. What all this illustrates is that space has weather. A highly technological civilization needs to pay attention to space weather, because a burst of solar material called a coronal mass ejection aimed directly at Earth could generate a debilitating geomagnetic storm. NASA and other government agencies are especially worried about a repeat of what is known as the Carrington event. In 1859, a coronal mass ejection struck Earth and caused telegraph lines to sing. A similar storm today could cause radio blackouts, knock out satellites, or even in the worst-case scenario, disable the electrical grid. That's why engineers at the Hopkins Laboratory and NASA want to cozy up to the sun and really understand its volatile atmosphere. But first, they had to figure out how to keep the Parker probe from being baked, roasted, immolated, or in some other fashion destroyed by coronal mass ejections and the solar wind. 2 pieces of technology are particularly crucial to mission success. The most obvious is the heat shield. You don't fly close to the sun without a good heat shield. The shield is coated with an ultra-white plasma spray to reflect as much solar radiation as possible. The surface is perfectly uniform to prevent hot spots and cold spots. The shield has a carbon foam interior, sandwiched between layers of a carbon composite similar to what you might find in a golf club or tennis racket. This 4.5-inch thick heat shield allows the sun-facing side to reach 2,500 degrees, even as the spacecraft body is a balmy 89 degrees, according to NASA. And there's another reason the spacecraft doesn't turn into molten goo. Although the temperature of the sun's atmosphere can reach millions of degrees, the density is low, so an object flying through that realm of space won't heat up easily. This shield will only work, however, if it is always directly facing the sun, with the vulnerable hardware behind it fully shaded. That requires precision navigation with multiple cameras that use the fixed stars as guides. The solar panels are nifty. Flying near the sun and then far away again is a recipe for power surges, so the panels can fold up like bird wings and tuck themselves away. Mission scientists also had to cross a major hurdle, the unbending laws of gravity. Believe it or not, it is extremely hard to get something close to the sun, Rawafi said. This is because a spaceship launched from Earth carries with it the angular momentum of our home planet as it orbits the sun. To steer a spaceship directly toward the sun would require an unrealistic amount of fuel. One possible solution would be to send the spacecraft out to Jupiter, which would slingshot it back to the sun. But that would take many years. NASA eventually opted for a strategy that uses multiple close passes of Venus, each time bleeding off some of the spacecraft's orbital momentum, allowing it to drift closer to the sun with each orbit. The Parker spacecraft has made 18 trips around the sun, and in late December it passed just 451 million miles from the surface, emerging from that scorching journey in tip-top shape. The probe has already gathered abundant data about the sun's corona, the ethereal outermost layer of the sun that's normally invisible to human eyes. The total eclipse on April 8th will offer people on Earth a rare chance to glimpse the corona when the moon fully blocks the main disk of our blazing star. NASA can precisely map the path of the moon's shadow and the timing of totality in every location on April 8th. For a heliophysicist, though, the big star in the sky is not as predictable as it looks. Among the things scientists don't fully understand about the sun is what they call the coronal heating problem. The corona is about 300 times hotter than the surface of the sun. That is contrary to common sense. As you move away from a campfire on a cold night, the air doesn't get warmer. But that's what it's like near the sun. Scientists have been trying to solve the coronal heating problem for decades. Data from the Parker probe, in tandem with observations during eclipses by heliophysicists on Earth, could put this one mystery of sunshine to rest. The tensest moments for the mission are when the spacecraft swings around the sun and temporarily cannot receive commands. That will happen this coming December during the closest encounter. For days, the team won't know if the spaceship survived. That spacecraft, it becomes part of your team, Fox said. She should know. Before she came to NASA, she worked at the Applied Physics Laboratory and served as the top scientist on the Parker probe mission. The probe is named after pioneering astrophysicist Eugene Parker. As a young scientist at the University of Chicago, Parker in the 1950s proposed the existence of the solar wind. His idea was initially dismissed and derided by many scientists, but it was confirmed by subsequent space missions. Parker himself attended the probe's 2018 launch. According to NASA, he was the first person to watch the launch of a spacecraft bearing his name. He died in 2022 at the age of 94. Parker had been astonished and thrilled, Fox said, when he first saw the spacecraft in the clean room at the Applied Physics Laboratory in advance of the launch. Then, as he watched the probe rocket into the heavens to start its historic journey, Parker became wistful, Fox recalled. Thank you for watching the video. If the video was helpful, make sure to like, share, and subscribe to this channel for the upcoming videos. See you in the next video.